All right, thank you, Wendy. Go to the next slide. Just a little bit about me. My name is Webley Bowles, as was mentioned before. I'm a sustainability director at WIP Sustainability, and I primarily support the development of embodied carbon related policies and programs, but I'm also an architect that's working in horizontal infrastructure. At WIP, we work to support organizations achieve their sustainability goals, and procurement is a major part of that. Next slide. In today's webinar, we will define what sustainable development is, present policy drivers for sustainable infrastructure and low carbon transportation materials programs. We'll discuss the tools contractors use to comply with many of these programs and policies, and present procurement opportunities for lower carbon products such as concrete, asphalt, and steel. And finally, we'll talk about the considerations in delivery. Next slide. Go on to the learning objectives. The learning objectives today hit on the agenda. We're defining sustainable development, explaining key environmental, social, and economic drivers, identifying where sustainable decisions are made on projects, and recognizing the common barriers and enablers for sustainable project delivery. Next slide. Yeah, so let's just jump right in. Let's get to defining what sustainable development is. Next slide. So according to the United Nations, sustainable development must meet the needs of the present without compromising the ability of future generations to meet their needs. We're addressing the triple bottom line, which really expands the traditional financing reporting to include social and environmental impact to achieve a sustainable growth rather than just focusing on profit alone. Next slide. These are the UN's 17 Sustainable Development Goals. You've likely seen them before. People have really great pins that they wear at conferences. These 17 goals recognize that ending poverty and other deprivations really go hand in hand with strategies to improve health, education, reduce inequity, and spur economic growth, all while addressing climate change and working to preserve our air, land, and water. Call attention to the middle row, items 9, 11, and 12 directly relate to the built environment. And 12 specifically is responsible consumption and production, and that really focuses on procurement. Next slide. So how do we put these big ideas, these 17 goals into practice? Sustainable infrastructure includes a lot of different considerations around site, water, energy, materials, and of course that social aspect. As Wendy mentioned, the next webinar in the series is from the Institute for Sustainable Infrastructure on the Envision project. It's a really great tool and rating system for horizontal infrastructure projects. So while many, and they're going to go into a lot more detail on many of these things. So while many of the sustainable infrastructure considerations are variable by project site, this is very site specific. The one core element that's not is materials. So when we think of roads, we think of asphalt, concrete, steel, maybe shaped rocks and aggregates. And this webinar is going to focus on those material choices because of their large environmental impact. Next slide. So you've probably seen this before, that the built environment is responsible for 39% of global energy use and carbon emissions. A subset of that 39% of global emissions is the 11%, which is from the development of construction materials and products. And when we look at infrastructure-related materials, that's primarily concrete, steel, and asphalt, that accounts for 8% of global emissions. So it's a pretty large percentage associated with these three materials. The building sector has really been focused on reducing energy consumption during the operations phase, so their energy use. And there's been more focus on low embodied carbon product choices to reduce their full life cycle emissions. And now state departments of transportations are also developing policies and programs that are considering the materials in roads and bridge projects to reduce their GHG emissions associated with procurement as well. Next slide. So this chart represents the life cycle stages of a construction product like asphalt or a full infrastructure project. So when we say 11% of emissions are associated with materials and products, that refers to the emissions associated with extracting, transporting, and manufacturing products. So kind of go from left to right there, the first three phases, it's cradle to gate emissions. The emissions from construction-related activities can be accounted for within the life cycle of the product as well. So there may be repair or maintenance during the use phase. So think filling potholes, for example. At the product end of life, there may be an effort to remove and transport the product to dispose or recycle of it, like recycled pavement. Next slide. Low carbon infrastructure policies and programs are being developed by public entities to meet their greenhouse gas reduction goals. And we're also seeing some private organizations develop requirements to meet corporate net zero goals. So all of these different groups are seeking qualified professionals who can deliver low carbon products and projects. Next slide. This chart on the right shows that 24% of GHG emissions associated with construction projects in the US can be attributed to public projects. So the things that jurisdictions are purchasing, whether that's at the federal, the state, the county, or the city level. And 9% of those emissions are associated with roads and highways. So jurisdictions are choosing to use their purchasing power to reduce emissions and support economic growth of lower carbon products through policies like Buy Clean. You might have heard of that before. These policies set a limit on the embodied carbon of select products for the public projects, while requiring that the products meets the same performance requirement of a conventional product. So it's the same performance, it's just a lower carbon option. Next slide. Knowing the environmental impact of the products they purchase, states have adopted policies and programs to drive better environmental and economic outcomes through their procurement. The blue states here on this map have Buy Clean policies for buildings and or roads. Those Buy Clean policies require or prioritize materials that are lower embodied carbon, and that's often represented through an environmental product declaration, which I'll get into in a little bit more detail here in a minute. The green states received federal funding to develop low carbon programs for roads specifically. So these are similar to Buy Clean in that they're prioritizing materials for lower carbon, but they're not driven through state legislation specifically. Next slide. In 2023, the US General Services Administration announced a new requirement for the procurement of substantially lower embodied carbon construction materials. GSA owns and manages over 150 border stations, and through legislation, federal funding is allowing these facilities to modernize with lower carbon products. So this facility that's here on the screen is one of the 10 most heavily visited border crossings with US bound vehicles. It's 40 years old, but there's actually insignificant queuing space, and it's in need of expansion to accommodate new types of inspections. So when we think of GSA, we often call them our largest landlord in the US. We think of buildings, but they procure a lot of concrete and asphalt at these facilities due to the traffic that they receive. And so they have a large sustainable material procurement opportunity here. Next slide. The Port Authority of New York and New Jersey has committed to achieving net zero emissions by 2050. And as such, they have a sustainable infrastructure program, which includes low carbon concrete and asphalt global warming potential limits. They're also now providing an incentive for contractors who can further reduce their concrete global warming potential limits. It's optional, but an incentive is incorporated into the selection process for a bidder who provides lower carbon concrete or asphalt at that stage. And their bid is adjusted during that review process. So it's a cool way, it's a voluntary option that really supports innovation. Next slide. Another driver of low carbon materials is California Transportation Department, also known as Caltrans, which has several low carbon programs. More recently, they've developed requirements for collecting environmental product declarations for concrete, hot mix asphalt, and concrete masonry units. And collecting these EPDs is going to support the state in understanding the environmental impact of their construction activities, kind of help set that baseline. But they have specific requirements, so not all projects have to have EPDs for every single product. They have different requirements on sizes as well. I'll also note that for Caltrans, their projects that include steel specifically need to comply with Buy Clean California requirements. That's one of the Buy Clean requirements that is not just to provide an EPD for rebar or structural steel, but it needs to meet specific GWP limits. So there's kind of two layers of policies that California is considering or is implementing now. Next slide. Similar to the legislative programs, state DOTs are starting to develop their own low carbon transportation materials programs. They're planning internally and updating standard documents while seeking feedback from stakeholders. Many of these low carbon transportation materials programs offer training and education to support the market so that they can comply with these new program requirements. If you're lucky enough to work in one of these states, I really suggest engaging with your local DOT for some free education for your staff. And not just to support the DOT, but there are private organizations like Amazon, Google, and Meta that are seeking lower carbon projects. So just a reminder, again, those states are Colorado, Oregon, Kentucky, Illinois, and Wisconsin. So while we won't go through all these steps here, these are kind of the high level steps that a Department of Transportation will consider for a low carbon transportation material program. They will need to understand the existing environmental impacts for the products that they're purchasing to know how to improve them. Then they'll work to develop education for contractors to deliver, and the local product suppliers are ready for this program. The DOTs are going to test the new materials and incorporate them into their specifications and contract documents, and then go through construction and bidding and selection into the construction and managing compliance. So there's a lot of steps associated with this, and it will be unique to each individual state and how they do their procurement. Next slide. If you're not in one of these states, or you may or may not have to meet these requirements, but maybe you're looking to develop your organization's own sustainable procurement program, you can look no further than ISO 20400. This is a guidance standard. Organizations are not specifically certified through it. The standard provides specific guidance for anything that you procure. It's a very flexible program. And of course, the Supply Chain School has a great course on this standard if you're interested in it. Next slide. So how do we deliver low carbon products and comply with these different policies and programs? Let's just jump right in. Next slide. First, we need to know what low carbon actually means. Low carbon is kind of relative to each product, and in some cases, it can change by location. So when we consider our life cycle stages, that chart on that bottom left, we also want to consider what stage. Are we looking at an individual concrete mix? Or are we looking at a full new bridge or tunnel project? In general, one batch of concrete is considered low carbon when its carbon content is 20% lower than a regional average. But that's really dependent on how a program defines it. It can be defined in a lot of different ways. Next slide. We measure the embodied carbon or the global warming potential, interchangeable, of products through something called a life cycle analysis. The life cycle analysis is the foundation for creating the environmental product declaration, the EPD, that specific tool that we're using for compliance. And since the details in the EPD are specific to a product, the product manufacturer is the one that's developing that document, and they're available from some databases or obtained directly from the manufacturer. There's standards and rules around the development of LCAs and EPDs. And of course, again, the Supply Chain School has your back there. They have a webinar on this topic for more information. Next slide. So the LCA provides some proprietary information about the product. where the EPD is kind of that public-facing document that presents the data consistently, and the data can be compared within the same product class. So if you're looking at asphalt, you can compare it to asphalt, but you don't necessarily want to compare asphalt and concrete since they're different types of products. Next slide. EPDs also provide information about the environmental attributes of a product. It's more than just the global warming potential. So most of these DOT programs are asking for the global warming potential of a product. But there's a lot more information in the LCA and the EPD, like the ozone depletion potential, the water use, acidification, eutrophication. The LCAs provide product manufacturers really helpful information to improve the overall environmental performance of their products. So while we're just looking at one thing, just know that these are really complex and have a variety of data in them. Next slide. Low carbon material programs often focus on the most commonly used products and those that are relatively higher in embodied carbon and have lower carbon alternates. So in transportation, go to the next slide, we're looking at concrete, asphalt, and steel. We'll look at each of these products and understand kind of high-level opportunities to reduce the global warming potential of each of the products. Next slide. So first we have concrete. What's concrete made of? It's a really simple and very complex product. Concrete consists mainly of aggregates by volume, but also contains cement and or supplementary cementatious materials, water, and admixtures. The pie chart on the right shows that the majority of the concrete emissions comes from cement production alone, specifically the clinker manufacturing. It's around 90 to 95% of the product's global warming potential. And the clinker is produced by heating limestone, which is a rock, to really extreme temperatures, cooling it down, and then crushing it. So it's a very energy intensive process. So when we talk about reducing emissions from concrete, it's often finding ways to reduce the cement content while meeting the same performance characteristics. Next slide. We also want to consider where the concrete ingredients are coming from. Cement comes from limestone quarries, which are often processed nearby limestone extraction sites. The map on that left shows the 110 plus cement plants are fairly evenly spaced across the United States, dependent on where you find good limestone. The concrete providers also will import cement from outside the US. And again, any sort of transportation is adding to the energy associated with that product. So it would be higher carbon to be imported. And aggregates, which are 80% of the concrete by volume, come from different types of rock quarries, but not all rock is the same. It's a very heavy product, so you're likely using something that's more local. And if the aggregate's of lower quality, your local concrete might require more cement to reach specific strength requirements, or maybe you're actually importing higher quality aggregate so that you have stronger aggregate and could use less cement. The more the product needs to travel, the likely you're increasing the energy to make that product. Next slide. So there's several opportunities to reduce the emissions associated with creating concrete. It's a really flexible and unique product in that each mix can be different. But because cement dominates the concrete emissions, most decarbonization efforts are focusing on reducing the cement and clinker content with supplementary cementatious materials, or lowering the emissions from cement manufacturing through plant energy efficiency or lower carbon fuels. And some of those efforts take years or decades to move those plant efficiencies forward. Another key aspect of reducing product level emissions is to optimize the structural design to reduce the overall volume of concrete needed on a project. So you might see this in like hollow core slabs or optimizing the shapes of columns to reduce the material, but you're still maintaining the structural performance. If you're working on a project with a prescriptive specification, it might indicate a specific cement to water ratio. And in this case, it can be very difficult to replace the amount of cement because it's dependent on that ratio. So the best specifications, and a whole nother webinar that we're not going to get into today, is to develop performance-based specifications for concrete. And that indicates kind of what the end result characteristic of the concrete needs to be. So that leaves the creativity up to the concrete producer. Next slide. Next, we have asphalt. Asphalt, similar to concrete, we're looking at 90 to 95% crushed stone, sand, and aggregate by volume. And then we have bitumen, which is a byproduct of crude oil refining, and it's really the glue that holds all the rocks together. In many cases, the extraction, transportation, and manufacturing of the raw materials accounts for about 50% of the asphalt emissions. And the asphalt plant itself, that burner fuel, is about 40% of the emissions. So where concrete, we were seeing all of the emissions were pretty much in the products themselves. With asphalt, we're seeing the actual heating of the fuel is where we're seeing more emissions. Next slide. So similar to concrete, asphalt's also a local product. So you're likely bringing in aggregates from local quarries, but you could be in a region with low-grade aggregate, and it would have low compressive strength. So you might be importing aggregate. This image is from a study that WIP conducted looking at a national global warming potential benchmark for asphalt. And we saw that a few states kind of stuck out a little bit. They're pretty obvious here. Florida and Louisiana have a limited supply of higher quality aggregates. And so they were transporting 3,000 miles, transporting aggregates 3,000 miles by ship. And that more than doubled their GWP for these products. And also note that they chose the right transportation option because shipping aggregate is a lower carbon transportation option. If they were to do it by rail or road, it would be much higher in emissions. Next slide. So there's several options to reduce the embodied carbon of asphalt. Increasing the amount of recycled asphalt pavement is number one. So if asphalt mixtures were to include 1% recycled asphalt pavement, it would be the equivalent of taking 30,000 cars off the road. So just 1% makes a big difference. Asphalt plant fuel is the second largest carbon impact in asphalt. So we want to reduce the asphalt mixture temperature, will reduce the amount of fuel that we're using. And many departments of transportation are experimenting with warm mix asphalt over hot mix asphalt. Also, a significant amount of asphalt plant energy goes into evaporating moisture from the aggregate. So it can be an overlooked thing, but evaporation accounts for about 40% of that burner fuel consumption. So if you are an aggregate provider, keeping the aggregate covered is really helpful to have a lower carbon because you're not actually dehydrating that aggregate. Next slide. So steel is our last one. Steel is 98% iron. It's also one of the most mined materials in the world by volume, but it's also a highly recycled product. Steel is made with either blast and basic oxygen furnaces or electric arc furnaces. Basic oxygen furnaces really depend on more virgin materials and is more energy intensive than the steel that comes from electric arc furnaces. And in the US, 70% of steel is produced with electric arc furnaces, which use significantly less energy and more recycled scrap steel. So steel covers a lot of categories in this, in when we're looking at low carbon transportation materials. It can include structural steel shapes, welded wire mesh, plate rebar, and a lot more. So it's not just the big heavy steel. Next slide. Steel is considered a globally traded commodity compared to concrete and asphalt, which are much more local. China produces over 50% of the world's steel, and US produces about 5% of the world's steel. But steel demand is closely linked to economic growth. And steel travels around the globe in nearly every sort of transportation that you can imagine, from ships to train cars to across roads to reach every corner of the globe. Next slide. Steel with higher recycled content often has a lower carbon profile, like rebar. Rebar is often 99% recycled content. As you mentioned before, the electric arc furnaces use less energy than basic oxygen furnaces, and we can improve the energy efficiency in steel mills, and we can reduce the emissions by about 10 to 20%. Again, changing these steel mills is a long capital improvement project, so it takes a long time. Lower carbon fuel is a key to achieving net zero fuel, either through lower carbon electricity or hydrogen-based fuels, which has limited adoption. Carbon neutral steel does exist, but good luck getting your hands on it. European automakers have really kind of purchased it before it even hits the market. So similar to concrete, steel design can be optimized to reduce the overall project embodied carbon emissions. So we can change the shape or kind of change the spacing of the amount of steel that we're using on the project. Next slide. So how do we deliver these lower carbon products? We know that there's programs that are they're very local, and they likely include environmental product declarations. If there's a buy clean or low carbon transportation materials policy in your region, I encourage you to engage with those who are developing the program. They're often seeking input because they know that they need your insights to be successful. So engage with your local departments of transportation, learn more about your local programs, take advantage of the free education. Regional and national industry associations like the National Ready Mix Concrete Association, National Asphalt and Pavement Association, and the American Institute of Steel Construction have webinars on lower carbon products that go into a lot more detail. This knowledge can really help give you a competitive advantage on other projects, not just transportation related projects. And finally, communicate with your teams, suppliers, and project owners. The more you can share your issues, your lessons learned, your tips and tricks, really anything, it's very helpful for others to know. You can create case studies, and chances that are that other people have similar questions. And as a first mover in this place, you can become an industry leader. Next slide. So there are hundreds of people who keep our roads open and safe, and departments of transportation staff cannot do it alone. When developing low carbon transportation materials programs, it's important that stakeholders are engaged at all steps. DOTs conduct long-term planning, they bring in community members, and they specifically need insights from contractors and product producers. Project planning may involve fewer external engagements with contractors until the project gets to a specific project planning stage. And bidding is where the contractors and the materials providers really show that they can meet or exceed the program requirements. Construction is where everyone kind of pulls together to deliver low carbon products that perform just as conventional products does. During this phase, we're also doing product testing, which confirms that the producers can deliver the products and meet the specifications. And that this is also where the contractors show their skills in installing lower carbon materials. Post-construction is where we see the results with lower carbon materials performing. And honestly, lower carbon concrete looks and performs just as high carbon concrete, but we know that we're improving our air, land, and water. Next slide. The Department of Transportation staff, contractors, and producers have different roles and impacts at each life cycle stage. Within the product stage, the one on the far left, it's primarily the product producer, manufacturer, who determines the carbon intensity of the product based on their plant. However, DOTs also have and can indicate a desired carbon performance of the product. And the contractor has a role in selecting the producer based on the design requirements from the DOT. So it does require everyone to be engaged, and everyone has an opportunity to select lower carbon products. Within the construction stage, it's primarily the contractor who is determining the on-site energy sources during installation. But the DOT could have specifications that require that trucks don't idle, or specific equipment is electric, and as I mentioned before, using a warm over hot mix asphalt specifically. In the use phase, this is an interesting place for DOTs because some DOTs will track the automobile emissions during this stage. So smoother roads can improve fuel efficiency, and optimal road design can minimize idling traffic congestion. But that's for definitely a different webinar in and of itself because it's not specifically materials related smoothnesses, but we'll get there another day. At the end of life, it's often the DOT that determines if the road is recycled in place or if the material is hauled off-site for future recycling. And for producers, they can take advantage of this C stage debris for their A1 product, so it becomes a life cycle. It's not just one decision that leads to low carbon materials, but it's many. Next slide. So we learned that there's still demand for lower carbon concrete, asphalt, and steel, with states that are leading the effort through legislative actions and DOT programs. Environmental product declarations, EPDs, are really that proof of delivery for lower carbon products. And we learned that there are several strategies for lower carbon concrete, asphalt, and steel. That's from plant efficiency for all these products to replacing the higher carbon ingredients with the lower carbon options. And those products can still perform the same. Lower carbon product related programs really benefit from collaborations with state agencies, contractors, product producers, and industry associations. So we hope that you continue the conversation and engage in local discussions on sustainable development, like these guys on the right that are checking out this low carbon concrete and trying to point out what's different. Next slide. Thank you for your time, everyone.
Thanks, Lovely. That was a really great session. We do have time for questions, so if anyone does have a question that I've not had a chance to answer in the chat, I will point out again that I didn't mention it this at the beginning, but this session has been recorded and will be shared to anyone who attended, so you will get a copy of that recording as well as the slides. If nobody does have a question, I had a couple questions, if that's okay, Lovely, if you've got time to answer them. I know that a number of us that are on the call might be in the larger GC designer architect space, but I do want to focus on maybe some of the smaller subcontractors, suppliers. Let's say you are a small business operating in this space. Maybe you're not getting a lot of guidance from your local DOT or state legislation or regulation. And you want to start, getting into providing more sustainable products or sustainable projects. What do you think the first, like, if it's kind of a daunting experience, what do you think the first, realistic first step would be to get more into providing sustainable services?
Yes, I think the best place to look for additional education is with either your national association. So I mentioned National NRMCA, National Ready Mixed Concrete Association, National Asphalt Pavement Association, NAPA. They have really great resources. And then also there's local versions of that in your own states. So look for your local asphalt group. There's often many, many resources. I've been really impressed with the national organizations. They've moved forward with adopting lower carbon materials pretty quickly, and they have a lot of resources on their websites that are available for everyone.
That's great. Um, Something that I've been doing a little bit, just for my own curiosity. Um, what do you make of the products that are like porous pavement, sustainable urban drainage systems, things that help prevent flooding, things like that? How do you think that fits into sustainable infrastructure in this space?
Yes, those are definitely choices and they're options. Like, as I mentioned in the beginning, when you're designing a sustainable infrastructure project, it's very site dependent.
Yeah.
Um, Using permeable pavement is not going to make sense everywhere. It
Hmm.
might not make sense in every single situation. It might not make sense on a freeway. Maybe it does in a parking lot, right? So you want to consider all of these different materials and strategies that are available for sustainable infrastructure, but they're going to be very site dependent and very focused on what are the goals of the project
Yeah.
and where can you use the most. So it could be a combination.
Hmm.
It could be a combination parking lot where maybe you actually have poured in place concrete for where the car tires go, but where kind of the open area where cars are and not resting on, it's more permeable. So there's a lot of different creative options out there, and that's where the design aspect gets really fun. And the Envision project or the Envision rating system really comes into play there and has opportunities for that.
Yeah, and that's just again a reminder that the Envision webinar that we're hosting that is taking place on May 14th at 1 p.m. Eastern Time. Would very much encourage you guys to join that session as well. We'll be going through a lot of case studies, a lot of examples from the Envision program. It'll be great to hear from ISI on that. If there are no other questions, oh, I've got one here from James. From your point of view, Webley, how can consulting engineering design firms contribute to the LCTM, especially in states that are not regulated? Hmm.
Yeah, so from a design standpoint, you can make decisions in design. You can also educate your local Department of Transportation. So in some cases, you might not need approval to make a lower carbon material change. In some cases, you do. So this is going to be specific to your Department of Transportation. As I mentioned before, there's some specifications are very close specifications, and they say your concrete mix has to be exactly this mix, and it cannot deviate. And in that case, you can have a conversation. You can see where that goes. You could see if you could help pilot something with the DOT.
Hmm.
So it doesn't hurt to ask.
That's right.
You know your client, so
Yeah.
that's a good place to start is to see what the DOT will actually allow and start to have that conversation about how to change it. And there are case studies out there that can provide some fodder for that conversation.
Great, thanks. So hopefully that answers your question, James. And yeah, just to reiterate your point, obviously when we're talking about DOT and like public infrastructure, safety is first and foremost, it's paramount, obviously. But there are certain standards that have been set that just haven't been looked at in a long time. And we are operating in a world that is moving very, very quickly, and there is a lot of innovation taking place. So yeah, I would just echo Webley's point. Ask the question. You never know. If you don't ask, you don't get.
Yeah. And there's also things that if you're pouring a concrete, you don't need an 8,000 PSI concrete. Maybe you do for the curb, depending on what the specification says, but you can change the some of the requirements based on what you are putting down. So just take that into consideration as well. You don't have to use the same concrete mix for every single surface either.
Mhm. Yeah. We've got another question here from Dennis. In which phase is it easiest for women, minority-owned businesses, etc., to get involved? Ah, okay. So this is an interesting one.
Yeah, easiest. Not sure how to answer the easiest question. I think the most important thing is that women minority owned businesses show up at every stage.
Yeah.
So be involved in your local chapter of your industry associations. speak up, right? That's a really important thing.
Hmm.
And uh, I think just sharing what's working and what's not is one of the most important aspects. Oftentimes in business, we kind of put our heads down and do the work, and even if it's good, we might not share it. So I think speaking up and saying like, "This was a really great project. Let me share these lessons learned here. This is how we built something that was just even 2% more sustainable. We moved the needle a tiny amount, and that's really important to prove that it can be done."
Yeah, exactly. And I would also go back to the ISO 20400 example.
Oh, good point.
If you are a larger organization looking to maybe increase supplier diversity, or you're just looking at how you want to make your procurement process more sustainable, it is a very good use, a very good resource, and would certainly help in terms of how you bake that into your procurement process, start to finish.
Great point.
We'll just leave it open for a few more minutes just while I wrap things up. If you do have any other questions that maybe you just didn't get to in the chat, or it comes to you after the session, Webley's kindly put her contact details up on screen. Like I said, the slides will be sent after the session, and the supply chain school is here to support. So if there is a question that you have that you want answered, just reach out, and I'll make sure that Webley gets your question, or a different subject matter expert who might be more appropriate. Happy to share the knowledge. That's what we're all about. If there are any issues with your platform, you should be getting a certificate at the end of the session, just to say that you attended. If you do not see your certificate pop up in your dashboard on the supply chain school, just reach out to me and I'll be able to help you out. But you will get credit for attending today, just to say that you were here the duration of this session, and that counts towards your CE credits as well. I think that is just about it. So we're going to give you back some time. Reminder again that the next session is on May 14th with ISI and talking about Envision, and then the session after that in June, we'll be back. We'll be back here with Webley to talk about sort of closing the loop, putting out these things into practice, and creating your sustainable infrastructure plans. So looking forward to that session. Just wanted to thank you guys all for being here again, and thank you to Webley for a great presentation. Thank you so much. I really appreciate everyone taking the time to be here today, and yeah, I'm looking forward to the next webinar. So we'll leave it there, and we'll see you at the next one.
Thanks, everyone.